Hello students, welcome to Sort of Sir's classes. We are solving IIT JAM Statistics 2015 question paper, and the problem in hand is we are given a 2x2 matrix, and which of the following equations does the matrix M satisfy? Now, characteristic polynomial of M is 2 minus x times minus 1 minus x minus 3, which is x minus 2 x plus 1 minus 3, which is x square plus x minus 2x, which makes minus x minus 5. So we know that by Cayley-Hamilton theorem, every matrix satisfies its own characteristic polynomial. If you have not seen this theorem before, please have a look at its Wikipedia page. Cayley-Hamilton theorem says m square minus m minus 5i is equal to 0, or m cube minus m square minus 5m is equal to 0. So B is the correct answer. Now we move on to our next problem. It says that if the determinant of an n cross n matrix A is 0, then the rank of A less than n minus 2, trace of A is 0, 0 is an eigenvalue, x equal to 0 is the only solution of Ax equal to 0. Now, since det A equal to 0 and A is from Rn to Rn, kernel of A cannot be equal to 0. Therefore, there exists x such that Ax is equal to 0 and x is non-zero. Therefore, 0 is an eigenvalue. So C, 0 is an eigenvalue of A, is the correct answer. We move on to our next problem. Let f from 0 to infinity open to R be given by fx equal to log x minus x plus 2. Then the number of roots of f is, now limit x going to 0 plus log x minus x plus 2 is equal to minus infinity, because as x goes to 0, log x goes to minus infinity and minus x also goes to minus infinity. And limit as x goes to infinity, log x minus x plus 2. Now before finding out this, let us see what the derivative of the function f prime x looks like. It's 1 by x minus 1. Now 1 by x minus 1 greater than 0 implies 1 by x is greater than 1, which implies x is less than 1. Therefore, if we draw a rough graph of the function, we have the point 1 here, and the function increases till 1 and then decreases. So 1 is the maxima. Now what is f of 1? F of 1 is equal to log 1, which is 0, minus 1 plus 2. So 2 minus 1 is 1. So f of 1 is actually 1. And so now we know that the function crosses 0 once before the point 1. The question is, does the function cross the 0 line, x equal to 0 line, after it? So that we can find out if we find out what limit x goes to infinity is, log x minus x. So now here we just make this substitution. X is equal to 1 plus y, and so x goes to infinity implies y goes to infinity, and so this can also be written as limit as y goes to infinity log 1 plus y minus 1 plus y plus 2. But now we put the Taylor series expansion for log 1 plus y, and it is simply y plus y square by 2 plus y cube by 3 and so on. Now we have minus y plus 1, y and minus y gets cancelled out, and this entire thing we know goes to plus infinity. So I've made a mistake here. Log 1 plus y is actually y minus y square by 2 plus y cube by 3 minus y to the power 4 by 4 and so on with oscillating signs. So the minus 1, the minus y and plus y gets cancelled out, and we have limit y goes to infinity minus y square times some function of y which goes to infinity, and we have a minus sign, so this of course goes to minus infinity and not plus infinity as I claimed earlier. So the function goes to minus infinity in the right side again, and so it crosses 0 exactly twice. So the number of roots of f is 2. The correct answer is C. Now we will move on to the next question. The number of distinct real values of x for which the matrix x11 1x1 1 1x is singular is. Now the way we go about doing this problem is calculating the characteristic polynomial. So we have, let us name this a, it's called determinant of a minus ti. So we have x minus t times x minus t square minus 1. If you take this and the next block, then we have x minus t minus 1 plus we have 1 minus x minus t. So this gets cancelled out. X minus t minus 1, the 1 and minus 1 and plus 1 gets cancelled out, and the x minus t gets cancelled out with the minus x minus t. But no, it actually doesn't get cancelled out, I beg your pardon. So here we have x times this, the next one would be 1 times 1 minus x minus t, so this is also actually 1 minus x minus t, and we have another 1 minus x minus t. Sorry for the mess up. This gives us x minus t cube minus x minus t plus 1 minus x minus t plus 1 minus x minus t, which is equal to x minus t cube minus 3x minus t plus 2. This is what the characteristic polynomial now looks like. So we have x minus t cube minus x minus t square plus x minus t square minus x minus t minus 2x minus t plus 2, which is equal to x minus t square plus x minus t minus 2 and x minus t minus 1. Please follow the steps carefully. So from this we get t equal to x minus 1, and from this we have x minus t plus 2, x minus t minus 1 equal to 0, which implies t equal to x plus 2 or t equal to x minus 1. Therefore, at 1 or minus 2, 0 is an eigenvalue. So 0 is an eigenvalue at 1 or minus 2, hence there are exactly two values of x where 0 is an eigenvalue. If you have any doubts or queries regarding the questions, please post it in the comment section. If you like the video, press the like button and subscribe our channel for more such videos. Thank you.